HW12 Q1 Part A. Here we're asked to balance an equation using that's our oxidation reduction reaction using the half reactions method. That just means what we learned in class, where you break apart the oxidation half reaction and the reduction half reaction and apply the rules. Balance elements other than H and O, balance oxygen using water, balance hydrogen using H+ ions, and balance charge using electrons. Then you add the two half reactions together, making sure that the electrons cross out. Notice that in this question they tell us that we have reactions that are in acidic solution, which is really nice because we can stop once we've added the two half reactions together. So let's tackle part A. The first thing we need to do is to assign oxidation states to all of the elements in all of the compounds in that equation. A couple of them are very straightforward. The copper, if it's neutral and alone, that's going to be a 0 oxidation state. The copper on the right side of the equation bears a charge, and so that charge is its oxidation state. We'll take a look at nitrate ion and the nitrogen monoxide on the product side. So starting with nitrate, between nitrogen and oxygen, the more electronegative atom is oxygen. So oxygen takes its normal charge based on position in the periodic table. Nitrogen's oxidation state is unknown initially. Let's do a little math to find that unknown oxidation state. We have one atom of nitrogen whose oxidation state is unknown. When added together with the 3 atoms of oxygen whose oxidation state is known to be -2, should add up to the overall charge of the compound, which is -1. X works out to be 5. So within the nitrate ion, nitrogen's oxidation state is 5. Oxygen's is -2. Now for the nitrogen monoxide on the product side of the equation. Same kind of a calculation. First we'll consider which element is more electronegative, and that's oxygen. You could probably do this one in your head. You have one atom that's -2 in its charge, and you have one atom that would have to take on some other charge so that when you add the oxidation states together, it matches the compound's overall charge, which is 0. Therefore, nitrogen's oxidation state has to be +2. Let's track what changed. In going from the left side of the equation to the right side, copper's oxidation state went from 0 up to +2. That means copper was oxidized. Nitrogen's oxidation state is +5 on the left side of the equation, and it's down to +2 on the right side of the equation. So its charge went down or was reduced. So nitrogen was reduced, copper was oxidized. Oxygen is -2 on the left side and -2 on the right side. So it was neither oxidized nor reduced. Okay, so that's an important determination. Now we can break it apart into half reactions and go from there. We'll label the oxidation and reduction half reactions. I'm going to list these one above the other. Oops. Okay, so the element oxidized was copper. On the left side of the equation, copper is just neutral. On the right side of the equation, it's +2. Applying our steps. Balance elements other than H and O. Well, that's done already. There's one atom of copper on each side of the equation. Balance oxygen using water. Well, there's no oxygen to worry about. We're fine on that one. Step 3, balance hydrogen using hydrogen ions. Well, that's not a problem either because there's no hydrogen ions to worry about. Lastly, balance charge using electrons. On the left side of the equation we have a neutral species, and on the right side we have a positive 2. We can only add electrons, we can't subtract electrons. So we'll add 2 electrons to the right side of the equation to bring the charge on the right side overall down to 0. And that matches what's on the left side. Now let's tackle the reduction half reaction. On the left side of the equation, the nitrogen-containing compound is NO3, and on the right side, the nitrogen-containing compound is just NO. First step, balance elements other than H and O. Well, there's one atom of nitrogen on either side, so it's already balanced. Step 2, balance oxygen by adding water. You'll notice that within the nitrate ion there are 3 oxygen atoms, and in nitrogen monoxide there's only 1. So to make the oxygens balance, we had to add 2 waters to the right side. But by doing that, we've now added hydrogen into the mix, and we need to counteract the presence of hydrogen by adding 4 hydrogen ions to the left side of the equation. Now the hydrogens balance, the oxygen balances, and elements other than H and O balance. But our charge is out of whack. Let's consider the charge of everything that's on the left side of the equation and everything that's on the right side of the equation as currently listed. On the left side we have 4 hydrogen ions, each of which have a single positive charge. We have 1 nitrate ion whose charge is -1. So it's like if I had $4 and I take away $1, I'm left with a balance of positive $3. On the right side of the equation, we have 2 chemical species, but they're both neutral. So the charge on the right side overall is 0. To make the charges balance, we can only bring down the charge on the side that has a higher charge by adding electrons. You can never take away electrons. So we'll add 3 electrons to the left side of the equation. In doing that, we knocked the charge down to 0, and so now there's a match. 0 on the left side, 0 on the right side. So we have a nicely balanced oxidation half reaction and a nicely balanced reduction half reaction. Now we need to add them together. When adding the 2 half reactions together, it's crucially important that the number of electrons cancel out. In the oxidation half reaction, we show the loss of 2, and in the reduction half reaction, we show the gain of 3. But those are not equal to each other. 2 and 3 are not the same numbers. So we've got to think of the lowest common multiple between those 2 numbers, which would be 6. To get to 6 electrons, we're going to take everything in the oxidation half reaction and triple its coefficients. And we're going to take everything in the reduction half reaction and double its coefficients. Upon doing that, we're left with Now we can add the 2 half reactions together. Notice that the number of electrons will cross out. That has to happen. So that multiplying of the coefficients is absolutely necessary to make the half reactions be able to add together. On the left side of the equation, starting with the things at the top. We have 3 coppers, neutral, 8 hydrogen ions, 2 nitrate ions. On the right side, starting with the top equation, 3 copper 2 ions, 2 nitrogen monoxides, and 4 waters. Thankfully, this problem is done in acidic solution. It's okay to have leftover hydrogen ions. If they had asked us to balance this in a basic solution, we would do one further step. We would add some hydroxide to cancel out the hydrogen ions that are there. But as it is, we're done.